Here is another locus question taken from the exercise. So we have these 2 points A and B, right, in red, in blue. But point A is rotated anti-clockwise about the origin 90 degrees to A prime. So let's recover A prime. Now anti-clockwise will be this direction. This is anti-clockwise, okay? So it is rotated 90 degrees. So I guess the point A prime will be somewhere here. Okay, this is kind of like A prime. Now it is in the 4th quadrant. A prime is in the 4th quadrant. It's very useful in the this rotation transformation. Think about the quadrant. In the 1st quadrant, x should be positive, y should be negative. This is how 1st quadrant points they are like. Alright, so 1 and 3, after the 90 degrees rotation, it changes to 3 and 1. If you rotate by 90 degrees or 270, you swap the x and y. If you rotate full 180, you keep the x and y. X becomes x, y becomes y. If it is rotate full 90 degrees, then x becomes y, y becomes x. Anyways, so this is A prime, alright? So we get the first answer. A prime is 3 and minus 1. So how about B prime, right? B prime is the reflection. Is the reflection in the y-axis, right? So y-axis as the mirror, we do a left-right reflection. So B prime is the reflection here, right? So once again, it's in the 4th quadrant. B prime is in the 4th quadrant. So 4th quadrant, we have positive x and negative y, alright? So 9 and 1, it is the plus 9 and minus 1, right? Left-right reflection. You keep the x, you keep the y. Okay, so that's A prime and B prime. Let me write down the answer. B prime will be 9 and minus 1. Alright. Now, so there's a P, right? The P is moving, so that AP is perpendicular to PB, right? That is the way about P is how P is moving. So if you recall some idea about the qualitative analysis, you know that this is a circle. This is a circle with the endpoints of diameters. Endpoints of diameter at A prime, B prime. A prime, B prime they are the endpoints of the diameter. Or alternatively, you can do it with algebra. With algebra, you can get the slope of PA prime and PB prime multiplied together is minus 1, right? So point P is x and y, and point A is 3 and minus 1. Point B prime is 9 and minus 1, right? You can do this so that you have y plus 1 squared and it's minus 1, right? And x minus 3, x minus 9 equals to 0. So after simplification, you have x squared and y squared minus 12x and 2y and 28 equals to 0, right? This is an algebraic method. You use m1 times m2 equals to minus, and there's a literal translation of this statement. Or you can do it with geometry, knowing that it is a circle with endpoints, diameter A prime, B prime. So the center will be the midpoint of A prime, B prime. Alright, this is an alternate method, right? You can do it in this way, or you can do it in the new way. Alright, so that is 3 and minus 1 for the center, 9 and minus 1. Alright, so the location of center will be at let's see how much is that. It's 6 and minus 1. That is the center. Alright, and the radius will be 3. Right, radius will be just 3. So we have the equation. It will be x minus 6 squared and y plus 1 squared is the square of 3. Alright, and I hope these two they are the same. Alright, you can pause the video and verify whether they are the same. Alright, you don't have to do it twice. You only do it in the algebra or geometry. Just one way will be enough. But we have the locus of P now. The locus of P will be this one, right? This is the locus of P. This answers part B. Alright? Okay, so we have a circle. Let me put back the circle. Alright, it's kind of like this. Alright, so we want to find the coordinate of the circumcenter of A prime P B prime. That means point P is here. We want to find the circumcenter of this particular triangle. In other words, we want to find the center of this green circle. Alright, so we did that previously. The center to that green circle is 6 and minus 1. Alright, so the center to this green circle is 6 and minus 1. Or you can obtain it from part B, from the general form. Okay. Now part D is interesting. Let Q be the centroid of this circle. Alright. Find the equation of the locus of Q as P is moving. P moves, alright, left and right, counterclockwise or clockwise. So the circle APB is changing. As it changes, there will be the centroid Q, right? The centroid Q is also moving. So what is the path traced by point Q? Alright. So we let P moves, alright. P is moving in the circle. So anyways, let P be the coordinate xp and yp. So xp and yp, they follow this equation, aren't they? xp squared plus yp squared minus 12xp plus 2yp plus 28 equals to 0. No matter how p is moving, the coordinate must follow this formula. Alright, so P is moving on this circle. Say furthermore, if I allow the coordinate of Q to be xq and yq. Alright, so do we have some way to relate xq yq to xp yp given it is the centroid? Now, if we want to do the median calculation, that will be too complicated. That is a shortcut that is extremely helpful. We know that the coordinate of the centroid will be just the 3 vertices add up divided by 3. Alright. xq, yq will be the centroid, and the coordinate will be, we add up the 3 vertices and divide by 3, not 2, divide by 3. Alright. We add up the vertices. So we add up xp, yp, and we add up a prime. A prime is 3 and minus 1. And we add the blue point, b prime is 9 and minus 1. So in other words, we have these two equations. We have xq equals to, or shall I say 1 over 3 xp plus 12. At the same time, we have yq equals to 1 over 3 yp minus 2. Alright, so that is relation between xp and xq, yp and yq. Alright, we may change xp as the subject so that we have xp is 3 times xq minus 12. Alright, and then yp will be 3 times yq plus 6. Alright, this is the relation between xp, xq, yp, and yq. Now, but xp and xq, these green numbers here, it should be 2, not 6. Alright, this green xp and yp shall satisfy this equation. So if we replace xp and yp with xq and yq, we have the relation between xq and yq. This should be yp. Oh, sorry, yq. I'm sorry. Alright, so we put them back. We have xp squared, 3 times xq minus 12. Take the square, and 3 times yq plus 2 squared minus 12 xp. 3 times xq minus 12 plus 2 times yp, 3 yq, and 2 plus 28 is 0. Alright, I just replaced the xp and yp with the corresponding expression in xq and yq. And finally, the exercise is to simplify this green equation. It's a very tedious, long equation, right? You try to simplify all of them, and now you may wish to pause the video a while and try to do the simplification. I will tell you the answer right away. Alright, I suppose you did the simplification during the pause, and we have the final answer to this one is xq squared plus yq squared minus 12xq plus 2yq plus 36 equals to 0. Alright, so this is the answer. You may change the xq and yq into just simple p and q, so that you have the locus of q is x squared and y squared minus 12x and 2y and 36 equals to 0, right? This is the better answer. Alright, so this is it. If you look carefully, these two circles, the circle for P and the circle for Q, they have the same center. They are concentric circles. The only difference is in the radius. Right? This is a funny observation, but it doesn't concern the question. Alright, so this is especially how do we relate P and Q, right? This is the important feature in this example.